What's up guys, welcome back to Vanover Customs. In today's video, we're going to be machining a brand new cross-feed screw for the Lion lathe. Now in a previous video, I showed you how you could repair a screw like this using an alternative method, and that works quite well. I'll actually put a link up in the card so you can check that video out. But there are some benefits to machining an entirely new screw from a piece of material. Mainly, it's going to be a little bit stronger because it is one continuous piece, and hopefully because we're going to try to machine this in one operation, it'll have a higher level of concentricity and just allow us to make the shaft exactly how we want to, eliminating any wear in any other spot of the shaft. So with all that being said, let me bring you in a little bit closer and we'll talk about some of the details of this screw that we're going to be making and what we need to do to get it done properly. In a previous video where we disassembled everything, we got into a lot of the specifics about the thread pitch and the wear and the uniqueness on this shaft, and I'm not going to get into that detail here. The long and the short of it is this shaft is worn in the center, which is really common, hence why we're making a new one. And what makes it unique is it's part metric, part standard. So the threads back here are metric, they have their own nut, and we don't have metric threading abilities, so we're going to convert this to a standard thread pitch and make a new nut off camera, and then we'll come in here and be able to thread this just like normal on the lathe with a standard thread pitch, and then once we're done, we'll come in here and cut the keyway. Other than that, nothing too crazy with making this part. As far as material selection goes, we're going to be using this stress proof. I think it's also 1144. The reason I'm using this is because it's a little bit easier to cut, and sometimes when you're doing these Acme threads, they can produce a lot of tool pressure, so having this stress-proof material kind of helps with ease of machinability, and also this material has a really nice property where it doesn't really move a lot, so when we're trying to keep everything nice and concentric and we're machining material, this should stay nice and straight. So with that being said, we'll get this material chucked up in the lathe and we'll get started. All right, let's come in here and get this spaced and center drill the end. We're running lots of stick out here, pretty much as possible, because I want to make sure we have enough room for the follow rest. That's the thing you got to watch out for when you're using a follow rest. If you don't plan it out, you'll get to the point where you'll run into the edge here and you won't have enough room. So we're running more stick out than necessary just to account for that. The next step on this job is to get out the follow rest and get it installed. Now we're using a shop-built follow rest for this job, and if you want to see me build it, there'll be a link in the card, and it's just attached with 3 bolts. One down at the bottom, and then 2 in the back. Now before we use this follow rest for the first time, I just want to touch on something that might be obvious, but really could trip you up if you just jump into using a follow rest. And that is that you want to make sure that your workpiece is long and straight. And that can be a challenge because a lot of long pieces tend to have a bow or a bend just due to their length. And the reason why that's important is because once you set this follow rest, if your piece is bent and it's running out, it's going to put unnatural pressure on the piece. And whereas with a steady rest where you can come in here and cut a nice band, you can't really do that on a follow rest because you're probably using a follow rest if you have a long piece. and you can't really come in here and make a cut along this length without it deflecting. So it's a little bit of a catch-22. You really are better off starting with a piece that's nice and straight. Otherwise, you're just gonna be fighting yourself when you go to use the follow rest. Luckily, this piece is pretty straight, so we're gonna set the follow rest up as it is here, and then we're gonna come in here and make our first cut. All right, here we go. I got everything set up. I'm gonna apply some lube. We're running at a slower RPM. We're gonna touch off, and we're gonna take the remainder of what we need to take in just one cut, because we only gotta take 12 thousandths off. Get some lubrication on those. Normally I wouldn't take the thing in one pass, but the dimension isn't super critical, number one, and number two, we only have 12 thousandths to take off, and this insert isn't gonna do well with like 2 thousandths. So we should be fine. Got whale oil as lubricant, it's real sticky. If we did our job right, we'll have a consistent measurement all the way down. Now that we got the shaft cut, it's time to start doing some preparation for threading. But before we do that, just real quickly, something really important here, you want to make sure when you're making these long cuts that your tailstock is lined up properly. Mine was close, but I needed to make a slight adjustment. By the time I got it dialed in, I was about 1/1000 difference in the middle. So I was at 76 here, 76 here, and 1/1000 large here in the middle. That could be due to the wear in the lathe. It could be due to a little bit of deflection. It could be a variety of things. So I just came in here and polished it and measured it up, and now we're within 1/2 thousandths all the way down, which is gonna be really nice for using that follow rest. So next we're gonna come in here and just cut our thread reliefs on both sides, and then we'll get ready for threading. So the drawing has 150 thousandths depth after touch off. We just touched our parting tool off the end. There's touch off. So we're gonna come in 150. All right, we were getting some chatter there. I should have known that was gonna happen. So we got the follow rest set up. Look at that, much better. Coming in here to 875 depth. And our parting blade is 120 thousandths. We're gonna back out and we're gonna come over 375 thousandths. There's our 875 depth, and we'll just clean this up. All right, there we go. There's our 875. All right, now this isn't in the drawing, but we're gonna come over here and just chamfer this just to make our lead in a little nicer. And then come over here and do the same again. This is flat on the shaft, but I'm just gonna chamfer it just cause. All right, cool. We'll do the other thread relief on the other end. Got our follow rest tightened up there. So for this thread relief, what we're gonna do is we're gonna come all the way down to the base of our depth of thread. And we're gonna use this kind of as a checker, so that way when we come across this thread relief, we'll know where the start or the deepest part of our cut is. So the drawing has us coming down to 864, which is less than the other one. but we're just gonna come down for now to the beginning of our thread depth so that we know where our max thread depth is, which would be 0.955. There we go. Now that we got that tightened up, should be good. There we go. And we'll just give us some room here to work. Probably what is happening is our brass is wearing as we're using it. And what that's doing is that's creating a little bit of chatter. All right, so now what I'm gonna do is I'm gonna come back to 955 and we'll just get everything cleaned up. We have a little spot where we're undercut there, but that's fine. This is just giving us a spot for our thread to run out and also just telling us where our maximum thread depth is gonna be, so that's perfect. We'll come in here and chamfer this next. All right, looks good. We're ready to start threading on the pacemaker. Let's talk about what we're doing before we start. So we're making a left-hand Acme thread, which is a little bit more unusual. So we're gonna be threading away from the chuck, and we're gonna be using an Acme top notch insert. The thread depth is gonna be about 100 thousandths of in feed, which is 200 thousandths in total, plus about 10 thousandths for clearance on both sides. So our total removal rate is about 220 thousandths. Now, typically what you're gonna wanna do is you're gonna wanna feed into the total depth that you're gonna wanna cut and zero both the cross slide and the compound. Then you'll back the compound out for clearance, and then you'll leave this set to zero and then slowly feed in the compound to make your cuts. And the benefit of doing that is once you come to a shoulder, you can quickly feed out with the cross slide, and then when you want to start again, you can re-zero this back to your zero and then just only in-feed with the compound, and that'll kind of prevent making mistakes. Now on this lathe, it's actually really nice because it has a cross-slide stop. So I already set my zero, and I can bring it in and it will actually stop there. So I'll check it with the DRO and with my indicator here, but for the most part, every single time I come in, it's gonna stop at the exact same point, which is really, really nice. So let's jump in there and let's make our scratch pass. All right, here we go. We're just gonna end feed a little bit and we're ready to go. Now, based on what I'm seeing, I'm actually gonna move this tool post closer to our follow rest. That way we have a little bit better chip action. We changed our setup and we got something that's probably gonna work a little bit better. We use this extension tool block so that we're much more in line with the follow rest. Now, ideally, we don't wanna hang our tool off the edge too far, but this is a compromise that we're making so we can get more in line. Had I known this, maybe I could have made this follow rest a little bit different. However, when you're turning the compound the other direction to cut right-hand threads, which is what I checked it with, it's a lot more in line. So it just is what it is. This is a really large tool post and is a pretty beefy block. I think we're gonna be completely fine. So we're gonna come in here and just continue our scratch pass. You can see a little spot where it didn't cut, where the gap was, where the follow rest was in this gap. And so having this tool pressure a little closer to the follow rest should make a big difference with that. So let's go ahead and make a couple cuts and see how we look. All right, I'm gonna dial in 5 thousandths, shouldn't be much. And here we go. Oh, look at that, that looks perfect. Bring it back to 0 to our threading stop. We're gonna feed in another 5 thousandths, and we're gonna come on every odd number here, or even number. And there we go. Get some lubrication. And as we get near the end, come in here, back out and disengage, and come back. Another 5 thousandths. I keep tightening up the follow rest, try to minimize chatter. Engage. Excellent, looking great. I'm gonna come in here and just kind of knock off the burrs. This is to kind of help the follow rest get as closely to the surface as possible. The burrs are going to kind of raise that surface up a little bit. My follow rest is nice and tight. We got a couple more passes to go. We're getting close. We're about 10 thousandths away. Once we get down to a few thousandths, we'll make some more spring passes and check it. The dimension isn't that critical because we're making our own nut, but we're trying to match the book specs as best we can, even though the outer diameter is unusual. Trying to get our follow rest set right as it wears. Always got to watch for that last cut. You're much more likely to get chatter. We're going to take a couple spring passes. All right, guys, this is our last pass, or second to last pass. We had a little bit of chatter on that previous one. We should be very close to depth, so we're just gonna take some spring passes, clean it up. All right, we do have some chatter there. We're gonna slow the lathe down and see if we can get that cleaned up. All right, we adjusted the steady rest or the follow rest. We have lots of lubricant. We got the RPM a little slower. See if we can clean up that chatter. Bring my tool in. Haven't changed any settings. In that one spot, we got some chatter. We're gonna run it even slower. It shouldn't affect the operation because it's deep in the groove, but we're gonna still see what we can do for correcting that. All right, let's see if we can clean up this chatter. We're running real slow. Ooh, that's working. It's working real nice. We got the threads cut and I could not be happier. They turned out nice and concentric. The depth is nice and consistent. I went ahead and wire brushed them off camera and removed the burrs, and it looks really nice. Next step is to come over here and just rough out and finish the rest of this side. So we need to cut a step from this point over and then work on threading on the end. We're just using a parting tool to come in here and come down to depth and then create a shoulder, and then we'll switch to a normal turning tool. All right, let's try that again. There we go. Coming down to 984. 990 is fine, all right. And then we'll come in here. Now we're just roughing it, that's fine. Now this is a bearing fit, so we want to make sure we don't overshoot it. Just kind of touching off and then backing out. I went ahead and moved the follow rest forward so we could have a little bit more stability and tighten it up. We're gonna come in here and touch off. I'm only gonna take about 2/1000. That should leave us about 1/1000 to clean up. We're not taking much off. It's easier to emery it down. All right, we're within 2/10 of our size here. I tested it with the bearing. It's a tight fit. I can barely get the bearing on. I don't want to sand it anymore. We do have a little bit of chatter here, but it's going to be covered with the bearings, and I don't want to remove any more material. We're going to come in here and chamfer both this and that. This chamfer isn't in the original part, so we're just going to lightly touch it, and then this will just help us with the threading. So we'll do a heavier chamfer here. And then we will come down, and we'll just barely break the edge. There we go, that's it. Let's get this ready for threading. Next step is to put a groove here for our threading runoff. The drawing specs it out at 118 thousandths. This insert is 120 thousandths wide. It will be totally acceptable to have a groove that's about 2 thousandths wider. Makes no difference at all. This is just a thread relief in this area. And we're gonna go about 34 thousandths deep. That is the same depth of our 18 pitch threads, so it'll give us a nice little gauge. Already went in and touched off the end so I could set it at the correct distance. So we'll come in, touch off, and come in about 34 thousandths times 2. My mistake there. We need to do 68 thousandths because 34 is just one side. There it is, right there. I'm gonna come in here with our threading tool and just kiss that corner to break the edge. That's it. That's all we need to do. And then we're gonna turn this down to 5/16, which is 9/375 in preparation for threading. And we'll actually have to make that groove a little deeper now that I think about it. I'm gonna come in here and grab a measurement. All right, we seem to be pretty spot on the DRO. About 1/1000ths oversize. Perfect. 9/375. In between the 7 and the 8. I know it's hard to see. All right, we'll come in here, we'll touch off here, and we'll make that groove 68 thousandths deeper than that. This, again, isn't super critical because we're making our own nut for this. Come in with our threading tool and just clean up both of those ends. This one already should be cleaned up. Yeah, that was just some dust. We're ready to start threading. Let's come in here and glue this up. Take a scratch pass. See how we look. I'm gonna come in here and just kind of touch off. Now I know this is gonna make some of you guys upset, but I'm just gonna thread with the cross feed. I'm not even gonna use the compound. It'll be fine. Such a small thread. It's not gonna be the end of the world. All right, here's our 18 thread pitch. All right, we're good. So we need to go 68 thousandths in feed. Start with 7, and we're gonna have to go on every one because we're working with 18 here. I'm gonna speed up the lathe. All right, we should be within 5 thousandths. Taking a look at the thread here, looks pretty good. Now, the measurement doesn't matter too much because we're gonna be making our own nut, but what I'll do is I'll just bring it all the way to 68 thousandths or 34 thousandths per side, and then we'll make the nut off that. The size isn't really that critical. As long as it fits with the nut, that's as critical as it needs to be. I'm just taking a spring pass here. Yeah, we didn't really lose that much there. All right, I'm happy with that. Let me come in here on the back and just get that last thread a little more ragged than I want. I should have done a heavier chamfer there. There we go indeed. I'm gonna put a heavier chamfer on the front and then we're done with this end. The last step is to work on this shoulder over here, and then we'll take it out of the lathe and cut the keyway. So I'm actually gonna touch my parting blade off over here, and we know that the shaft is 36 inches long, so we're gonna use that to measure this guy out. Now, ironically, my DRO, for whatever reason, stops at 36 inches. So we're gonna bring it right up to 35,801. I can just zero it and then go the last amount, which is 319 thousandths. And now you see why we started with so much stick out, because our follow rest still clears the chuck. So we're gonna get a tape measure out here and just verify this. Should be dead on the money, 36, and it is. So we're gonna come in and just make a mark with the parting blade. That way we know that's where our end is, and we'll go from there. All right, now that we got the follow rest moved, I can come in here and make that cut. I'm not gonna part all the way through, I'm just trying to get an end point. Perfect. All right, we're gonna come in here and machine this shaft down now. We got this shaft finished out within 2/10. Last step is to get this parted off. We're not gonna part all the way through, that'd be really dangerous. I'm gonna part down maybe a 1/4 inch left. We'll chamfer the end and then we'll finish it off with a hacksaw. I'm gonna zero my X. I'm gonna come here and apply a heavy chamfer. Come back to my zero mark. And we'll come in. Again, we're not gonna part it all the way. We'll get it close. There it is. Got about a 1/4 inch left. Should have a nice face side, even though the parting blade isn't leave that great of a finish, it doesn't matter. We have our length set. We'll come in here, we'll remove the follow rest. We'll take a hacksaw, cut it off, and then we should be all good to go. Come in here with a precision instrument. There we go. We got it halfway through. The best way to do it, get it cut halfway and then just bend it off. That way you don't drop it. There it is. The last step is to cut the keyway. Now this would be really easy to get up in the mill and just take an end mill and buzz it out. That would work just fine. But I figured, hey, why not? Let's use the K&T and a slitting saw and try to make it just like the factory one was made. So we got the machine set up. I got everything trammed in. This bar is running within 0.5 thousandths of parallel and the vise is trammed in. I touched off on both sides and on the top. We're gonna make it in a couple of cuts. Let's see how we do. We're on 1.25 inches per minute. I thought for sure we'd be good with that feed rate and that RPM, but apparently not. All right, we got a new cutter. Let's see what we can do. There was a hard spot in there we had to get past. We're just making our cleanup cut. I offset both sides and came up to final depth. Well guys, I am really happy with the way this turned out. This is the type of project that may look simple but can definitely throw you for a loop. The main thing you're fighting here with the length, if you don't have a follow rest, is chatter, deflection, concentricity, and because we had that follow rest, we were able to make sure that this piece is very concentric and nice and smooth and will work perfect for what we're trying to do. Overall, our threads turned out really nice down here. This bearing fit is very nice. It's within 2 to 3 tenths. This doesn't matter, but it's within maybe 0.5 thousandths. These threads are consistent the whole way within maybe 0.5 thousandths. And then over here, this shaft is maybe within 2 tenths of where it needs to be. And the keyway is maybe 3 thousandths oversized on the depth, which is completely fine, and the width is within 1 thousandths. Those tolerances are a little bit overkill, but hey, I just wanted to kind of push myself and see how accurate I could make this to the original part, all the way down to the slitting saw for the keyway. Now, we did have one little boo-boo over here with the slitting saw. I haven't used the K&T a ton, and so I hit the lever in the wrong direction and it cut into the side, but that's not gonna make that big of a difference. And to be honest, you can't expect to get a project like this with all these features without making a mistake, or at least I can't. So that type of mistake out of the whole project was in the 9th hour, and to be honest, that's something I can definitely live with. So overall, super happy with how this turned out. We're going to be using this to fit and make the new nut, which will be out of bronze, so that will be the next video. I will make a new nut for this end over here as well, but I'll do that off camera, and we should be good to go. If you guys have any questions, post them down below, comment, subscribe, and we will see you in the next one, guys.